Hello friends, today we're going to start with big integers in JavaScript. Okay, so what are big integers and how to use them? Uh, you could see that I have made some examples, and to save your time I have written them down, and we will try launching them and check the outputs. Okay, so the first one is this one, the page1.html, and here we are using the integer precision. Okay, so here integers, JavaScript integers can show you accurate values up to 15 digits. Okay, so here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so up to 15 digits it will show you the correct value. If you try to do something more than that, it may not give you an accurate value. So let's say I added 5 more, so that's 20 and 21. If we try to reprint that, you can see that it's missing the sixth one. Okay, it's not giving me the sixth one properly. Fifth, sixth, yeah, the sixth digit is not shown here. So it works correctly up till 15 digits. Okay, and that's the reason we came up with big integers. Okay, so all numbers in JavaScript that are stored in 64 floating point formats, and I that is IEEE is 754 standard. Okay, with this standard we can use large integer values. Okay, and that can exactly be represented, and you can also sometimes round up to the next value. However, you will get a value correctly with big integers. Okay, so here you can see that b and c a b and c, they are all big integers. So if we comment this two out, it's going to give me proper values. Oh wait. All right, so if here a, b, and c, these are all big integers. Okay, if we give the proper value to these three numbers, okay, 56. This is it's printing in the n format. Okay, the n is for now. Moving on, we have two big integers, and we are trying to check the value of big integer. And if I make it like a type of b, it's giving me a different result. But let me restart the program. Now you can see that it's giving me that the type of b is big integer. The n is for number. Okay, the last n, it's for number. Okay, all right. So in the previous example also, it was giving us an error on the in b. It gave an error like after 10, 15 digits. Yeah, it gave us a different number value. However, in this one we are not doing anything like that. It's just printing the value, and it's giving us an yeah, you can see this one as well. In 999, it's giving something different on the yeah, in between the values. Okay, certain numbers are different. Okay, but when we try to print what type of value is b, it says that it's big integer. So these type of differences come up when you have a big integer. Okay, so you have to be very careful with while working with big integer values. Okay, now we will move on to the multiplication part. So big integer multiplication is like we have two variables with two big integers, and we are trying to multiply the value, and we will see what's the output. So we're rerunning the program, and we will see that what's the output. Now when I rerun the program, you can see that the second digit is of some different values after the printing. But when we try to multiply them, we get another big integer. So d is another big integer with an n precision in it, like the number. It shows that it is a number. Okay. Now we will move on to the next one, which is uh, hmm, decimal. Okay. There was an error. Yeah, to the decimal part. Okay, now here I'm going to show you one error. Okay, where it will show you an error. Let's restart the program again, and you see what I did was a is of type of big integer or 5n, but when I'm trying to put mix it with in b, so a with an integer, it says that big integer cannot be mixed with any other data type. So here if we try to overcome this one, we will have to stop. printing and stop working on that value, then we will have everything correct. So now it's doing uh, it says there specifically that we took a same kind of value in C, and we converted that to a number, and then we are dividing it by 2, and we're storing that in D, and this time D gives a 2.5. Okay, it's actually dividing 5 with 2, and it's giving us a 2.5 result, and it's not throwing an error. So it's pretty much able to understand what's there. Okay, so how things would work on this one, so it's pretty much able to understand that one. Now, moving on, we will go ahead to the hexagonal part. Okay, so here I have another example which has a hexagon and octagon and a binary. Now we will try to print those values and see how it works. So let's restart the program again. And here you can see that the binary is giving us a different output. So console.log binary, that's giving us 360 something output. Okay. And also the hexagon and octagon, when you try to print those values, it's giving us some different values depending upon the uh, hexagonal, hexadecimal, octal, or binary conversion. Okay, notations. So yeah, now we move on to the next one, that is precision curiosity. So precision will be the safe integer, hexagon, sorry, the max safe. Okay, the max safe and min safe. This max safe and min safe, it sometimes rounds up the values to the next one. Okay, so if I'm trying to print console.log a, you can see that 992 triple equals to 993. So you can see that while we are comparing two values, it's giving us a true. Why? You can see that 992 is here and 993, so it's trying to round up the value. But if I change this value to something, let's say 1, and I try to recompare that, it gives me a false because it's not closer even. Okay, so whatever is it's close, 991 was uh, anything that's after that and it's close to it, so it will give us a true. Let's say if we make it absolutely the same, it will give me a true. And if I'm trying to go with a value higher than that and trying to compare, then also it will give me a true. But too higher from that value, it will not give me a true, it will give me a false. Okay. Similarly, we have two values, number dot min safe integer and max safe integer, and they have some fixed values. So min safe will go to a negative value, and max safe will give to a positive value. Okay, and that's giving us the value of those max safe, min safe integers. Okay, so moving ahead, we will go to the safe integer. So what is a safe integer? So these were two new methods. So this was introduced in ES6, and these were two new methods to the number object. Okay. Now we will check is integer. So let's stop this program, restart this program so that it will give me the correct value. Now it's returning us a true and false depending upon the value. So number dot is integer. If 10 is an integer or not, it gives me a true, and if it's a decimal, it's giving me a false. Similarly, we have um, is safe integer. So is safe integer, it is also an integer that can be exactly represented as a double precision number. So is safe integer method, it returns true if the argument is a safe integer. Okay, so this one, it's returning us true. But when we're trying to is safe integer, we are trying to put in a big int value in it, and we're trying to check that, it's giving us false. Okay, so it says that it's not a safe integer. Okay, so normally safe integers are integers from negative 2 to the power 53 minus 1 until positive 2 to the power 53 minus 1. So those are considered as safe integer. Other than that, any values beyond that range is considered as unsafe integer. Okay, so with this we covered up our big int. Ahead we will continue with the same JavaScript bunch, and we will have few more things coming up. So until then, stay connected, stay tuned, and happy coding. Thank you.